All right, Ed and I got three 2-inch XPS sheets back to the shop. We had to break one of them by accident, but that's okay. We calibrated our little bandsaw setup here so that we're making, 8 uniform, quote-unquote, 6-inch strips. More importantly, we've got 8 usable pieces instead of 7 with an 1/8 that's a little light, which we figured out on the first try. So we did a measure inside here. We don't know exactly what the kerf is, but we sliced up the the small half of a broken sheet, and found out we weren't left with quite enough on the last pass. So I just scribed our makeshift fence and then knocked it over until the pencil line wasn't showing anymore, which essentially gives you 8 kerfs, 8 line widths, roughly equal to, heavy pencil line equal to the kerf. So now we're going to put full sheets through. So we'll watch that, and then we'll get it back to the site and get it installed on the footer. All right, y'all, welcome back. We are getting the XPS foam up on the edges of our concrete floor pour, and so we'll use the laser. Now the footer should be quite level, and we were careful to rip these all with the same setup on the bandsaw as you saw, but we set them out all the way around the room here. Now I've got, things in the way of the laser and stuff here. But overall, about 50% of the room has got the laser on it from this location. And we're up into the laser a little bit over here, which is kind of where I started. We're a little high in the corner here. Now I was testing, we got a few different things at play. So to start with, as I was discussing, I kind of want to screed the concrete level with the top surface of this foam. If we've got the concrete sitting a little higher in some places, like if we paid no attention and we just put our rips of foam tight to the footer all the way around, he's going to want to screed to that anyway. But if he's trying to set it to the laser, then the laser is a little higher in these places and lower in others it's harder to see. The easiest thing to do is work with the lightweight foam and set its edge to a laser line that you're comfortable with. Now this is my project basically, so I can set it to the laser line to the extent that I'm comfortable, and if we screed the concrete to that laser line, again, I've made my peace with the concrete being at that level in this place. So it's up onto the foam a little bit here, but it's downhill kind of everywhere from here. It sits above the foam over there, it sits above over there, meaning that if we pick this laser height, then we can sneak the foam up the wall to where it's just grazing. I'm just seeing like it skim across the whole edge. See that? I'm getting it on the whole edge or down onto the foam. Just you got to make a few concessions here, but that's basically where we'll set the foam all the way around the room. And so then the top surface of the foam is a great deal more level than even the footer. So despite the fact that the bottom, when we lay the foam down in here on the floor, it's going to lie where it lies. But our edge will work out to a minimum 4 inches at least. And anywhere that we're a little bit deeper in here, we use a little bit more concrete, which is not the end of the world. I'd rather that than put more time and effort into making this stone super perfect, because as you can tell, we did what we thought we needed before, and now we're right back in here working again. It's just the nature of it. I'm going to try and get everything done to where we just put the foam down, and then we're thinking about packs on top. But we still probably have to come in here and deal with something we weren't planning on, and it's just how things work. So another problem that we had is how to put this up quickly. So I got these Spax washers. Sorry. This is the Plasti-Grip insulation washer that I picked up. They've got these little points on there which make it handy to, push them in. And they're roundabout, the same as the stuff that was, or the things that were used outside to put the waterproofing up. Those are pre-perforated. They've got a hole through them. Whether or not you shoot through the hole, but they're solid, and they're apparently polypropylene, although I guess these ones are polypropylene too. They're just a little bit more lightweight. So a bag of 50 did almost everything we need. We probably have to get another bag of 50. But then the question became, shooting a nail through it. Well, you can get green concrete nails for shooting into green concrete, which this is. It's only a few months old, or less than that. These are New Fast, America's premium nail, but they're 2 1/4 inches long. Now that's all the longer they make a concrete nail, because if it's called a concrete nail, you need to be able to plan on shooting it in practically all the way into green concrete. If you get any longer than that, which is what we need to hold up 2-inch foam board, we're only asking a 3-inch nail to go in a little under an inch. But they couldn't sell a 3-inch nail because you couldn't drive that thing all the way into concrete. You'd be hurting your gun and risking your safety to put it flush and try to drive that all the way down. So you run out of overall length. So what are we going to do about that? Well, we did a sample. Ed's going down to the building department now to see if it would be allowed. But basically we wanted to know if you just hit one of these squares with a hammer and get a 1/2-inch divot going, then you can shoot it in and it will bite enough to hold it on the wall. But will they let us compromise the R value and the structural integrity 5 or 6 times per stick to put that up? So I see they're actually calling me right now while I'm talking about it, so I maybe call them back in a minute and see what they finally say. One way or another, if we can't make the divot, we'll have to drill and screw into the concrete the same as we did to hang the downspout loop on the concrete wall, which is possible. Ed and I could get both ends set to the laser on every piece, and then he can go around and at the middle bring it up or push it down until the laser's right, drill and screw the middle, and then kind of mindlessly probably turn the laser off and just mindlessly do the other two. If you notice, every 8-foot stick has got one at either end, one round about the middle, and then I split the distance between them. So anyway, those last two could be done without really even having the laser on. But it's a lot of crawling around on your hands and knees or bending over at the waist or whatever and drilling and screwing. It just takes longer than just bam, bam, bam. So he's checking on whether or not we can basically countersink it with a hammer. We'll come back and find out if that is acceptable, and then we'll, one way or another, get the edges on. Meanwhile, I can't wait for the mason, I don't think, to come after we've done the floor and then lift against the new floor to replace that with concrete blocking, or shim there, basically, in a technical sense. Because we're just squishing that floor with the styrofoam under it, which is cantilevered out all the way around. And I'd be too worried about putting a big crack in the floor. It's in some ways a very legitimate worry, and in other ways like a completely illegitimate worry if you've got more familiarity with stuff than I've got. And I have quite a bit of familiarity with it. It's hard to say. I drew it up in cross-section and gave it to the architect to tell me, 4,500 PSI concrete, whatever the compression strength of the styrofoam is, a solid 24-inch square footprint of the cribbing, because I'll add a couple blocks in the bottom, unlike I've done out here. But that way it's a solid footprint, and you can get the surface area of that. And then you can figure the load that's on the jack in this area that, once you completely take it over, if it's translated to that size footprint, is that too much pressure basically on the foam? If the foam is going to give way underneath that pressure, to start with, is a good indication. But then you've got the resistance of the cantilever of concrete slab over that foam, which contributes some resistance, and that's about which we're either going to hold up or break. And so, I don't know if you have to plan on the concrete being cantilevered into space and imagine the foam's not even there, or give the foam some compressive resistance for that. I don't know exactly, but I can't also expect him to get right back to me. The safest thing for me to do if I get through some other things here today is to take the weight off of that, make up a little mortar and get a block in there and get it drying, because then tomorrow I can take the weight out, move the cribbing out of the way, put the one last little piece of foam on there, and immediately we can start filling in with foam all the way back and forth to here. before we've got to do the same thing down here. Meanwhile, I've got the time in the world to do that. This is a part of last video that I haven't even done already. I'm working on insulation, but I wanted to wrap up that loose ends video with moving that toilet flange. Really, this lifting is part of that loose ends video too. That might end up in that. But for right now, we're in the insulation video, and this is the point that we're at here. Stay tuned. Well, this idea that Ed had for countersinking that was cool, and I just put a scrap up on the wall and it held when I shot it on, but I don't know if you can see the nails just bent, and it did it over here also. Where are we? Right there. If you find a stone just under the surface, that's all it takes to bend the nail. Now the nail's trapped in the foam due to the bend, and this piece is sort of monkeyed up beyond all recognition. I just don't think that's a viable way to go about doing this. I had tried regular framing nails. They bent over out here. It's going to be hard on the gun, making the nail the weakest link in that chain, because it's going to be pretty darn strong as a straight heavy steel pin, and so the pin in the gun that drives it, I don't want to ask it to do that too much. So I think we're down to probably drilling and screwing, which is more controlled. It's just kind of a pain. I'll probably take that piece out and sub in a different hole piece and just see if I can't drill. Oh, I gotta go get some longer screws too, because I want to use the 3/16, the lightest concrete screw that I can, since we aren't asking it to do anything structural, and it'll be cheaper that way. And I gotta make sure that I get enough, so it's about 5 per stick times 15 or so full sticks. So, you know, see what kind of groups they sell them in and go get that, and then come back and start screwing stuff on. Alright, I've been trying not to directly overlap this stuff. I'm going to put the loose end stuff in the loose ends video and try to keep the insulation stuff in this series now. And so while I'm waiting on, because there has been actual back and forth, so without further ado, it really doesn't matter. More importantly, we're down to the idea that while incidentally it would work to hit that with a hammer enough to countersink it and shoot the nail on, I think more reliably it's well worth just screwing it up, and just screw it right up. I got some of the longest small diameter Tapcons that you can get. I got a full pack, which ought to almost do us, and I haven't decided whether I want to do all 5 positions on these full lengths. Essentially, I'm going to get both ends to start with based on the laser line. I'm going to see how the middle looks compared to the laser line, and then do that. It might be right where it needs to be, but I have the flexibility to go up and down with the middle and shoot it on based on the laser, and then there shouldn't be any kind of deflection between these two sort of fasteners in this position. I may very well not feel that I need I likely won't need it to outline or constrain its elevation. I may want it just to push it tightly against the wall, although of course when the concrete comes it will do that itself anyway, and so we'll look critically at whether or not we want the second box of screws really, and whether or not we even need the second bag of washers, just as a heads up on that. So that's my methodology here. I've also got stuff in the way of throwing the laser all the way around the room, and so I'm not absolutely sure, beyond a shadow of a doubt, that the highest point of the footer is over here. I've been working as though it is, so I just want to kiss the laser line in this position, and then everything else can be slid up off of the footer a touch all the way around to sort of get there, rather than thinking I've got it like that, and I get around and there's a position that's actually even higher, and therefore then I start to have to custom cut the rips of foam to sit the top down to the laser, or reassemble everything a bit higher up at that time. So I'm going to try and come up with some kind of easy check to make, rather than moving all this stuff all over the place, because I won't be needing the laser after this operation down here, and so I basically don't want to go to all that much effort. I've got it on a piece of 5/4 material in this position, and I've been thinking, once I put as much up based on this laser as I can here, I can relocate the laser over there to throw itself all the way down that wall, you know, without worrying about what's behind us anymore. And over here, I can move it up and down until it's essentially right on the top edge of the foam that I've already put up. And I'll know that position, whatever it is, and the one that I started with are close and near enough. It makes no difference. And then continue on my merry way. But checking to see that that's the highest part of the footer that way, if I were to move the laser over here to see, I have no relationship between where the laser is in this position and where the laser is over here, if that makes sense, which complicates matters. And so I may actually move the laser itself to this position and see how it relates over there, but also I can see how it relates down at this end, which is sort of the furthest reaches from where its position is now, and just that's enough to double check that my work is correct, that this is the highest point of the footer. And if I run into something over here, well, then that will set to there and then translate it back. All because we chose to put the foam in here, all because we want to have the foam ready and waiting for us when we get to that point, and now we can't, get around it all with the laser transit. And I kind of want to look at the line, because I could obviously go up high enough to get on the wall over there and measure down all around, but that's one more bit of an extra hand that I haven't got, or two, to run all those things. And so anyway, long story short, this is how my brain works in deciding what exactly to do next. I want to be sure of my start point here, and then it ought to go kind of quick, just getting both ends drilled and screwed into the wall. And I'm also going to leave probably the rest of that for Ed, because at that point, I can get our site measure that's been completed that shows these posts in their final resting place and the actual physical dimensions of the concrete and their relationship to one another, which is a bit different than the drawing we initially submitted. And so now I've got a very accurate representation in my CAD of this actual footprint and these posts and the stairwell wall thereby and all this other stuff here. So in the CAD, I can go back after I get the ends of all these pieces of foam up today, basically, because there's more than enough time in the day here. I can illustrate, I could fill that area with a grid to scale to 1 feet, squares. And then once we get the foam in here, I'll start that grid, by the way, in the CAD right here in this stairwell wall where I want all the circuits of PEX to terminate. So we have the ability to put as much or all of the utilities and pumps and everything for that system someday, somebody does, underneath the stairwell closet, or some or all of it on the other side of that wall, which is around the corner in this room that will be, over to here, sort of Ed's sort of old workshop room sort of thing. Gives flexibility on the other side of this known interior wall. We could do it on this wall that I intend to have under the basement stairs, but then you're either inside the closet or out on a very apparent sort of outside facing wall. And any other interior wall would be better than an exterior wall, because then you've got to try and get behind everything and insulate it. And not only that, we've sort of consumed from here through the washing machines, this temporary bathroom, the stairs, any interior wall space in this room if you haven't got to have it in there by putting it on the outside wall. Whereas this option here, if you don't like a bunch of stuff on this wall in this room, you can put as much as you can fit into this stairwell. Whereas if you put it on the outside wall in here, you've got to have it there, and you can't be moving the PEX lines after you've got them in the floor, and you really don't want to splice into them and go far away, because that splice could be a problem in the future if you can help it. So an interior wall is better, and we don't want any other material. We don't have any other interior wall plans, right? So far, we just know that this wall will be here, and it's the more private and the more options with this wall. Therefore, we get to this is the wall where the PEX is going to come out of the floor. And so I will bother to snap a line basically down the center line of this beam, which is right on the plans that I have right now. And that will practically, that's going to be the center line of a grid line where all the PEX tubes come out, and then we'll offset our 12 inches all the way down till we're roughly that from the outside wall. However it works out, we'll offset them up this way, that way, and we'll trim this up. And in CAD, we'll have a 1 foot grid based on this line. And then in the house, once we get all the styrofoam down, we'll snap that line back on here, and we'll measure off of it from there to the wall and get our 1 foot increments, snap our line across the room like this, snap our line the other way like that, doing the same thing, and then all the way back down that initial line with 12-inch increments, down the firewall and here, the other side, snap, 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 so we got chalk 1 foot squares on the styrofoam that's directly related to that grid in the CAD. Then, whether or not we printed the CAD, and then we'll to scale, and we'll make ourselves some 100 foot long string, to scale with that CAD printout, and we will design 100-foot circuitry or whatever I determine to be. We've got to make sure we've got some sources on this, but it's roundabout like that. You don't want any particular circuit to be much longer than a certain amount because you end up running out of energy before it comes back to be reheated, and you don't necessarily want to run everything out initially to the outside edge, or maybe you do, or maybe you don't. So we're going to double check that theory when we plan these routes with the string on the CAD printout, and then we'll use highlighter to commit to those on that printout. And we can, chuck the string or whatever. But we've also got 100-foot lengths of string that will give us a very accurate amount of PEX that we're talking about looking to purchase. And at that point, we've just put a chalk grid on the foam, which won't take more than 10 minutes, probably 20 minutes, better part of half an hour, or start to finish. So if we look at everything and we decide for any reason that we don't want to have to do that, it's no harm. We can just get right into getting, basically say we're ready for concrete. But if we want to translate into the PEX, we can buy as much as we know that we need now, and I can have basically Ed save himself the cost of my time and get that laid out himself or with a helper, and we can just landscape staple, just push right down into the styrofoam to hold it, which is just fine for it to be on the bottom surface of the concrete. At that point, we're either going to lay that mesh out on top and hope to pull it up into the pour so it's sort of in the middle of the pad when they're pouring, which is fairly common. But we had been concerned about saw cutting anyway, and that was why I wanted to keep the PEX to the bottom of the pad and not tie it right onto the mesh because the mesh comes up closer to the surface. But then I was discussing it with my dad, and he goes, we didn't cut the floor in our project when we did it back when you were a kid. We put fiberglass in the batch. We chose to do that. Sean's dad did. And they never saw cut anything. And he only had one little hairline crack or something inconspicuous for a couple of feet or whatever. It ultimately made no difference. So I have to talk to the concrete contractor and see how he feels about omitting the mesh, maybe just in here, maybe still wants in the garage, whatever, and using the glass, whatever. But if we leave the PEX at the bottom, to start with, it's a step in the right direction. And if we can put fiberglass and skip the mesh even, my dad wasn't sure that we had the mesh in the pad because there's nowhere for the pieces to go. If they crack, they do the mesh essentially, if it should crack, should keep it aligned and planar and everything, and should give it that, which is what we were fighting against when we cut this pilaster down. There's two components to this construction style: the massive compression strength and density of the concrete, and the unbelievable what do I want to call it? Toughness of the steel that's trapped in there. So anyway, maybe we can skip the mesh. We could get about $500 back for all of the mesh, or a good portion of money back for some of the mesh. That may offset the fiberglass cost in the concrete. So we will be looking at all of this stuff while I get down to whether or not we're going to put the PEX down on the foam. But at this point, I know that we're going to get as far as the grid on the foam and the grid in the CAD, and using the string will determine how much, how many linear feet of PEX we're talking about buying, which is kind of all the material that we're going to want, and the landscaping, staples. The chalk line is is free or whatever. It doesn't cost you anything. The CAD printout or something large format, a few bucks. So anyway, it's going to be cost effective if the PEX isn't too much. And then it's always in the pad, and we've got a drawing of that designed to submit to the town. So if someone wants to do something officially here and hook that up someday and make it part of the primary heat, or for whatever reason wants a record of it, we've got a map. So that's sort of what's on my mind today. Is I'm going to get these foam pieces hung to where they meet my satisfaction overall, and then leave the busy work end of it for Ed to wrap up for me, and then head back out and jump into the CAD and get that grid up and running. Then, just as a small aside, that gives me over to tomorrow before I load. That gives that a full 36 hours before I load that mortar. And and I'm doing what I can do in front of it. I could set it down right now, but if I should have a failure, then I've got to go backwards and rework it. So just as soon give it somewhere between 24 and 48 hours at least. And so tomorrow morning, the first thing I can do is load that and move that whole cribbing assembly and lift down here and get that constructed and curing up, which gets us cleared out, get the monolithic concrete pieces out, touch up that stone, whether or not we compact it, whatever. But at that point, if we've got the edges up, we can fill the insulation across the room to practically here, and be looking at more than halfway done. Certainly probably the easier half, rather than in and around all these things and in and around this whole situation, like in and around there. But I'd be feeling good if that was the case by the end of the day tomorrow, and that leaves another day this week, I believe, for us to. That would mean it would cure all day tomorrow, and then overnight to the following day's morning would be 24 hours. So that's Friday morning. Is really like to go to the end of the day Friday before I take that down. But we could be ready we could get even probably this 8 feet to where the cribbing's going to be here. So we could get this sheet in. And hell, if we're careful on this edge, we could measure down 8 feet and then pick up and resume. It's obviously just one. So we could get up to and around what I'm doing here. And then that stuff goes out the back window and we just finish. So very close to, if not completely done with loose ends, which you'll see long before this video. And then done with insulation by the end of this week. And then we'll do some coverage of getting that PEX down. Hopefully we end up doing that much. All right, anyway. Blah, 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 blah. Watch me screw this foam to the side of the concrete wall. All right, so this is pretty irritating, but you know, if you've got any kind of a surface like that, you can get a hold of it. See, by the time you're out on a washer, you're another 1/4 of an inch away. So you end up with about a 1/2 inch of engagement with these even. So I think I might even have to hit these areas with a hammer as a solution to that, because in any of these areas that are less than complete fill at the surface where you need it, I get no engagement. So I guess we'll try just hitting these ones with a hammer. I've only gotten 1 out of 3 or something so far. Not a good ratio. All right, I moved the laser over here, and I've got it just on the edge. Everything's relative, so long as that's where we are around the room practically. And it's hard to see, but we're within a ½ an inch in terms of level all the way around. Something with these automatic leveling lasers, they always seem to have, like, I don't know, an 1/8 of an inch in terms of tolerance from setting and resetting and everything remaining the same. The quality of that automatic level, for whatever reason, seems to change a tiny bit. Just as a craftsperson who's built and designed and constructed so many different things since I was a little kid, I just have a feeling when I use it, given everything about what I experience, that there's something that's a little bit of a variable there. So they're very useful. It's one of the fastest ways. I mean, I bought that thing so we could straighten this beam out. I mean, there's no other way to work by yourself in here and do a meaningful job of leveling everything in a space this size. In fact, my dad and I built out a barn 5 or 6 years ago, framed out the entire interior, and during that project I bought both my laser transit and my 8-foot level, which is here somewhere. Prior to that, we'd been using a 4-foot level, and as the story goes in my family, my dad and his brothers were pouring concrete, I want to say, in the cow barn when they were kids, and all they had was a 2-foot level, and they used it all the way around the barn. And when they got back to where they'd started, they'd compounded their error to some crazy amount, inches. And so that was unnerving at that time. And so since I've had that laser, that was like the biggest project that I'd done at that time. And now I always rely on the laser. So it's an important investment. The transit's different than the plain laser, which is different than a laser level, and by little differences. So you want to keep aware of that. So anyway, that being said, it came in clutch here. We're looking real good. At some point here, when things are all picked up and out of the way, and we're going to get this EPS out because that's going on the wall, but it's not going to go up until we're done with the floor, so that's coming out of here. So at some point, we'll set the laser back up in here where it can basically get to almost everything from over in this corner, or actually over here. That would be the way to do it, right off the end of this wall. Then you'll get all the way around in there. You get the face of the wall, practically down and all the way around here and back. And at that point, we can slightly dial up. Maybe we could wait. No. I'll get the EPS foam out before we start putting the XPS down flat. So that much more is out of our way. And we can do that much to dial the perfect edges of this to all one laser setup. So at least relative to that one setup, we've got as much accuracy as possible rather than compounded setups. Just as a best practice here. This is where I tried several different methods on this piece, so he's still loose. That one goes in there. There's a couple around the corner that have been pre-made. 1, 2 right there. I'm gonna get tools and stuff picked up, consolidate all the pieces of foam that aren't spoken for to be used places. This isn't bad as far as leftover. And like I say, I'm going to see if Ed wants to finish up attachment, but we want to maybe do it all from the same laser setup, so I got to stay ahead of him on that. And then we'll just wait over till tomorrow morning to set that beam weight back onto that little block, but that's, again, part of another series. This is the insulation series, so let's head back to the computer and make sure that we've got a grid layout and an accurate footprint, and we'll print that thing and start planning our PEX layout. Oh, another thing that I'm thinking about the PEX layout is that training all the ends to be exactly in the center line of this wall will be easy, because I can actually attach something temporarily like a 2x4 between this post and this post on that center line, and I can drill it all on the drill press prior to hold a bunch of conduit elbows to control the bends as we turn to come up and out of the concrete and to protect those little delicate PEX tubies. And so that board or whatever that we secure here will hold all the elbows and they'll spin. And so then we can let circuitry come in at any angle all the way 360 degrees as it makes sense to. But then when they go vertical, they all come up on the exact same plane. And as we commit to those, I can construction adhesive them, the elbows to the wood, Better not do that. That's the thing, is we want to keep this thing in place, but it probably can't represent, it shouldn't represent the sole plate of that wall, because it's going to be hard to work up to it with the concrete. Although if we come through it, it's going to be a good question there of what exactly to do. I want those conduit elbows to stick up through the surface of the concrete, and I want them to then go up into the wood that holds them in the right location. But I probably want a gap between the two things. So anyway, we'll have to look at that. Is that something that I want to be able to take away once the concrete tightens up, and tool as closely to all the conduit as we can, all consistent and homogeneous with the surface that we're troweling and tooling all around it. And so, we haven't got some kind of weird cast-in sole plate to the wall. Although in the end we may end up with that, because if we're committed to the PEX tube and we're committed to the stairwell, we may as well commit to the sole plate of the wall. It's a real good question. And then the concrete would just be finished up to both sides of it, because it's going to stop and start on that post anyway. This is the one that's in larger diameter, so we're just going to be on the same center line. It's going to be a 2x4 is flush to either side of that post. If we commit to it and hold it, by screwing into a couple vertical 2x4s, and then like plumber, what do you call that? Pipe clamping, band clamping those verticals that are screwed to the horizontal to the pole, and perforating that horizontal to carry the conduit. Maybe that all stays in place, and then we're done. Trowel all around, whatever. And then before we take the band clamps away, maybe drill and screw down with Tapcons into the new plate, or to the new floor, to hold the plate onto it permanent, and then take the band clamps off, and I guess toenail those verticals so that those can be taken back off. Unless you wanted to go right up and put the top plate on, and the verticals are actually just the ends that go down. Maybe that's the thing to do, is build the wall frame in. Go ahead and band clamp it to hold it and make it level, and set the bottom of it to hold the same plane as the top edge of this foam. Yeah. And just leave it to be the wall forever, and trowel around it all the way. Then that piece of plate there, whether or not there's a doorway or the wall stops or whatever, we're all free. But this here is a commitment that just stays in place. And then worst case scenario, if you want to do something differently, you could take those screws out. It would pop up. There'd be a rough witness on the floor from where you didn't trowel the floor smooth before applying that sole plate. But that really isn't that big of a deal in the scheme of things. If for some reason you completely give up on the PEX floor, you completely give up on the stairwell wall, and you really got to get in there, and you rip that sole plate off, and you cut those PEX lines and conduit elbows that are plastic off flush with the floor, and you grind whatever bumpiness down, it could be used as subfloor, and you could put underlayment and do whatever flooring through there. And I really haven't screwed anybody, although they've really shot themselves in the foot given the effort that we've gone to. So maybe that's what we do. I think that's kind of what I settled on right now, is that in that place. So that's going to be part and parcel of our design for the circuitry here. So like I say, let's go back and sit down at the computer and get that much done, and then we'll get it out onto the foam here in real life when we're done with that. All right, Opal. This is not that helpful. I got back to the shop here and spent the last couple hours of the day working with Ed's site measure, which is what we got the architect, so we can start our as-builts, so that we can give those to the town, and so the town can have a record of what we actually constructed here. It's really difficult to get my initial measurements to the architect and have them be functional now. There's so many layers of siding on this thing, and so many ways in which you can't easily add up. If things aren't at 90 degrees, the longer the lag of what should be 90 degrees, the more and more inaccurate it could be to add this dimension, and that dimension. Because if this is an acute angle, well, that's a shorter dimension out here by tiny amounts and stuff, plus all the other different reasons. Over in here, we had that crawl space originally, and it was difficult to get up inside and to see whereabouts, whatever. So now we've got hard dimensions translated onto the initial architectural drawing that was submitted to be able to pull the permit for the project, which has got all the dimensions on here to remind you to make sure that check all these different aspects of something. And then Ed jotted, it should have been redlined, it should have been in red, and everything should be. I really like things, even though this drawing has got these written like that, horizontally, and on vertical dimensions they're written vertically. I can't stand that type of thing because it's got you turning drawings all around like an imbecile, and so it happened again. Anyway, I'd written everything horizontally and in red, so it's easy to identify because I was in and out of these values a bunch of times here. It's just a bit of best practice. But in the finished sketch space, which is left over from basically what I made to get these measurements over to the architect initially, I've touched all these up so that they are accurate and current, and then I made the dotted line grid as we discussed. Here is that column. This is the big 4-incher, and these are 3.5 inchers. And this is the original exterior of the house center line, and it works out on this line of the grid because, of course, I started there so that we're on that line when we come back, like I say, between here and there, so which is going to be where all those lines come in. And so now we can print this out, but it's got to be to this D scale. This is an easy 1/24 is easy. It's 1/2 inch equals a foot. So we'll, like I say, be able to make pieces of string. If we're looking for 100 feet, we can make, a 50-inch piece of string, and we can, zigzag it back and forth here until it's been consumed. It looks like about a half a dozen circuits and that's including the garage, which I left under the same grid because if we're going to come in on those routes, and maybe we'll head right over. If we're doing the garage at all, we'll swing out with the first few things, go straight over, up the wall, and right over to the garage and zigzag, and then back to those. It's going to take some figuring, but this is what I'm going to give to Ed so he can putter with it and give him the parameters of what you can and can't do. So we'll get this printed out, and that's about the cost. My couple hours here, and the print, and the PEX itself, and the time spent putting it down onto this, designing it and putting it down. As much of that as the customer can do, and as long as it's in keeping with the general parameters for doing something like that, you ought to be in good enough shape. I'm in kind of a tough town on this. They want to see a record of it, and as far as I'm concerned, it's not the primary heat for the house. We are not going to finish it and don't have to finish it to close out this permit. We're simply choosing, we could choose to do this in the wall somewhere. We could choose to kind of add this feature to our construction at our own expense, to me, it seems. And, whether it works or it doesn't or something, is kind of like it's on us. But they are being funny about it. Most places in rural America, you probably don't even have to do this much as far as showing the town what you're going to do. I may be wrong, but so this is what I have gotten us down to, and then we'll come back and look at what we come up with in terms of a design, and then what that means for linear feet of PEX and whether or not we're going to do this whole thing. Ooh, welcome to the Matrix. All right, we just wrapped up loose ends video by getting started with the plate compaction again. Now we just finished up the plate compaction as far as I'm concerned. And more than compacting, which we were certainly doing, I'm looking for this very slightly rolling smooth plane, which is our best case scenario. There's still going to be a lot of noise coming from the styrofoam as we walk on it all the way up until we weigh it down with concrete, but best case scenario, we got to get that. I'm going to do one more pass on the footer with the leaf blower, get all the little dust and debris. More importantly, the full-blown stones, that's my new band, that are up on it there, and we'll be looking to sort of, maybe I'll run over there with the plate compaction. The problem with plate compaction in these tight spots is that the collateral vibration of everything, and it'll tear up the foam if I get too close and bump into it, which happened in a couple spots. So it's less than elegant and it's less than perfection that we're going for, but we're trying to get close using basically the tolerances that we have got to accommodate from those tools. So this is looking pretty darn good now. I can feel that it's a little low and a little high in places, but that's just all we're going to be able to do. We'll get the styrofoam down, and then we're off and running. All right, let's put these boards down. Get this place covered up. That'll be satisfying. I'm gonna try and keep as much stones and grit out as I can, even though we have a real nice heavy moisture barrier. That's why it's so heavy, so that you can have foot traffic and stuff on it. But we'll do what we can down here. Let's see how long this takes to fit up. It's going to start getting more complicated as we get down this way and fit around all these items, and then finally around into this at the back. And I had to drop a chunk of that concrete right on the edge here on my way out the window, so that's kind of munged up, but those are about that far for right now. I really hate to, my dad, first thing he would say is just bury it and forget about it, but I really hate to leave that area. He might agree with me, but right here, maybe not. Maybe far away. Not right underneath or next to the house foundation for a variety of reasons. All right, let's see what this takes to get done. Well, that's the meat and potatoes. We've got a couple little slivers to get. And I might run around with some great stuff foam if I felt silly. Gotta get that in. This piece over here. But overall, over here, I didn't realize I could set the sheet down that close to the top of the sump crock because of the stupid radio. The second time around, I realized that would work great to get close enough to trace, which it did. And the other thing is I pulled a measurement here of 27.5 inches, but then I went and put 20.5 inches on my sheet, and so my arc that I eyeballed would have been way closer to what we needed if I hadn't made that. I do that all the time. I'll get the tens and I'll get the fractional inches, but I'll miss the individual inches on a measurement when I take it. I don't know what my brain does, just pieces out. So Ed can finish these loose ends up, and then day after tomorrow I'm gonna get, oh, I guess it is, he could have put this sliver over here, I guess, but whatever. And we'll do the same here probably. Oh no, right there, we'll need to go down the wall. So we're not out of square too terribly much, which is good. When we build in the finished walls down here, I will take and make, I'm fairly certain, I will bother to set this wall's floor plate and this wall's floor plate perfectly parallel to one another. This plate, and this plate perfectly parallel to one another, and those at 90 degrees to one another. So we'll have a little more gappage here or there behind some of these walls as we square the space out completely, which just makes it easy to do things like put a ceiling in here someday if you do drop ceiling and some other things that are just, it's certainly easy enough to do. You got to put the wall somewhere. Let's just put it on a 100% squared out floor plan. So in that, then we'll end up with a really nice level plumb walls, squared space with a fairly level ceiling, and then all the rest of the work in here will be quite a lot easier as well. So I'm gonna get started probably outside on the front wall, tearing it out, at least get that demoed out of my way, and then we'll see how much farther before the rain that's supposed to be on the way, but I don't see it yet. Well, time for lunch first. Well, we're rained out of working on something else on the site, and we've got the foam down for the most part. So I am working on laying out the PEX. Now, the first thing you might think when you glance at this is, I don't know the first goddamn thing about planning PEX loops for a radiant floor. You'd be mistaken. This is an idea of the length of PEX we need to buy, and I wanted to do it all in one color for the house and a different color for the garage, but I ended up running out of red, so I jumped into using the blue. I'm not going to be putting in a T like this or there or anything else. I just wanted to, within the footprint, consume the linear feet of this grid completely, which is why I use this little piece and stuff here, to get an idea of whether we need 500, 750, 1,000, 1,200. I'm trying to buy PEX in a reasonable amount, and if we could split it between deciding between to do the house and the garage, I think it's going to be a no-brainer to do that. So I started here at least, which is, if you look at this location, that's the big post that I had to move into the butt crack between the two piers that are not quite in the right spot, and here's that post that gets us halfway to the wall. And this is where I say I want all the PEX to come out of the sole plate of the wall, so I'll end up putting the sole plate in with the holes through it for the PEX to come through if we do this, and we'll just trowel up to that 2x4. Looks like my tenant's home. Anyway, so what I'll do now is I'll pull this all. Now I broke it here, and this garage is all just the one piece, so I know when I measure the length of him, I know that's what I need for the garage. I measure all these pieces together, I know that's the amount of pipe that I need for the house. And this is a 1/2 inch grid and a 24 inch or a 1/24 scale, so a 1/2 inch equals a foot, and so however many inches long, twice that many inches is the number of feet, right? And then we could start with pieces of string that were cut to about 200 feet long, because you don't want to go much shorter and you don't want to go any longer than 300 feet, I guess, in a circuit's length. And so then we'll find out whether we need 2, 3, 4, I don't know, circuits in the floor. But first step is to peel this off and get a sense of the linear feet. Okay, so this is a few iterations. You can see all the fuzz here from, I misted this with Super 77 spray adhesive, and then I could lay out and relay out and change the embroidery floss, which is what I ended up using here. There might be some improvements to be made. Obviously, using the computer is one thing, but routing and rerouting a line of about a certain length, where I was willing to go a little longer or a little shorter for the sake of this arrangement, is all quite a bit specific. And so it really isn't all that handy to use in typical CAD. You kind of need more software. You need a program designed for doing this, or maybe a plug-in or something a little beyond what I wanted to deal with. So I just pulled it out into the real world and used string. Easy enough. We're all in this wall with all of our ends. The color's irrelevant. I just ran out of the red, which is what I wanted to do. But another thing you want to think about is, do we take off with hot water on the left-hand side of this circuit as we're looking at this, and go down the outside wall and come back finally to the right of it with what comes back, cooler, having contributed its energy to the floor. And then if we stick to that, then we leave with left here and we leave with left here. But over here, this circuit, if we leave with left, then we go all the way around the inside first and cool off before we swing around and go around the outside with our coldest route, as we cool off and come back here. That's obviously easy enough to switch or whatever, but kind of when you get into the wall layout, you want hot on one side, cool on the other, generally speaking, unless you try not to cross anything here. So you want to be thinking about that. And a lot of times blue and red is used to designate, warm and cool. So don't get hung up on the colors. In the end here, this is pretty close. I sent a photograph of this. I sent the CAD file with just the grid on it. And some of the other things that we, are planning on. The toilet here, I left some room around it so that we're not overly making the wax ring too warm and soft. That may or may not be an issue, but I just felt that here we're going to have enough collateral heating. Obviously, we got to go around the shower, which ends up right on one of these lines. The sump crocks in the corner, I'll probably swing out and around behind it with one of the routes. You never know. This was the best situation I could find. The other thing I wanted to mention was this puts us right down the center line of the main beam, where the posts are, which is kind of where you're going to want a saw cut. So I might have taken this grid, and rather than being so close to 1 whole foot, see here, 1 whole foot's right in there, but this is the concrete, so we got to imagine we got 2-inch foam board, and then we've got, so this is actually going to be 8 or 10 inches from the edge of the concrete pad. And so if I were to slide the whole grid to the left, we'd probably get a bit too close. We could stand to get a little bit further away from this wall, and that would move our route off of that saw cut line down through the middle of the building. But we are going to saw cut. If we do saw cut, you would go out to either side of each post, because each of those squares can then shrink down and away without constricting around something. You put posts and things in the, corners of your relief cuts, your control joint cuts, because if they were in the piece that you were to cut free, well, then when they shrink, you'll crack over to them. So posts and things like that are always, on the end of some of your relief cuts. And I wanted to come and go over to the garage here, which goes all the way to the center and comes all the way back. So this is my best guess, long story short. But I did manage to find a place locally that will review this and make whatever changes and then stamp it to some level of certification, having been engineered. I was just trying not to go down a whole rabbit hole of, what's the BTU and flow rate and all of that, which would need to be figured out in the future. And it may need to be figured out to some extent to be able to plan this effectively. But I can't imagine that it would. We're just designing a radiator here. Like any other radiator that you would, know what you're going to put to it and what you're looking to do. It can kind of be spec'd out from the data, I think. It's just a question of, like I say, taking the heat out to the outside where you're losing it versus taking the heat to the inside first and then coming around the outside when you're all done. Those types of things are going to be something that they can work out for us. It's going to take a few days, hopefully be pretty economical. So anyway, we'll get that far, and it'll be interesting. We'll compare what I did here, off the cuff with what they come back and do for us. and we'll just see what that looks like.
Whoa. I'm just sort of thinking about this issue today that seems small, but it's another way in which things can spiral out of control on a project like this. So I'm just inclined to share a bit of what all is going on. So we're down to, this is, I don't know, we'll put this in the middle of the insulation / floor prep video, which is what I think it's going to end up being. And so I got to the end of last week, so it's currently Wednesday, and I had planned to pick up the moisture membrane barrier that I ordered last week Friday from the supplier. And so again, toward the end of last week, I could see that I would be down to wanting that, by the middle of this week. And so I figured up until that point, we pour concrete every day in most places around my country, so there's going to be membrane around. So I get down to Friday, and while it's still the business day, I'm calling around or looking for where I might get it locally, and I couldn't find any locally. And so I started with what the box store wanted to, charge for a roll that would have to ship to me. And I did some calling around to see if ordering it would be any faster through, smaller places or industrial suppliers, and if they could do any better on the price, which they could do a lot better on the price. It's like 20 or 25% cheaper. So I said, over the course of the conversation, I wanted to know not only that, but you got to have the tape that sticks the membrane to concrete, and you've got to have the tape that sticks the membrane to itself for all the cuts that you make to fit around it, fit around stuff. So this place that I finally got toward the end of the day Friday, who could get an order placed for me by the end of the day, and who would have something for me by like Wednesday or Thursday at the latest this week, he had everything but the extra wide tape to stick it to concrete. And I really, for some reason, was thinking, I really want to go with the extra wide tape for concrete, because I just can't see this thing sticking that well. And if it maybe sticks once, but if I got to make changes, yada yada, I figured it's first time using the stuff, we'll splurge and we'll order in the extra wide tape. So anyway, I even gave him my credit card information and everything, thinking he would, charge it and I could just pick it up and run with it come Wednesday. So today arrived. Now yesterday I really couldn't get any farther. I left it with Ed to get the last pieces of styrofoam cut and fit down, because he can do that. I'm not trying to have them pay me for anything that somebody else could do on this if there's somebody available at the right time, and Ed has been very available, and it's been good. He's saved himself quite a lot of money. So yesterday wasn't a paying day for me, and so the first part of this morning wasn't a paying morning. And so then finally I called to see if it's arrived or would arrive, and they say, well, we're still waiting on the truck, and then it's coming up on lunchtime and I want to catch people before lunch. So I call again, and I guess it hasn't even shipped. It didn't ship, this thing. So then I started thinking, geez, I said to the guy, that sucks, blah blah blah. He said, well, I can't do anything for you, it'll be the boss that can help you out, and he'll have to call you. I said, so have him call me. So I got a haircut because I needed one, and I got to thinking, like, I got to exhaust all my options, and I have a couple more options. I could call the guy that's given me a number on pouring the floor, or I could send him a text, and I could see if he knows of any place that's got a roll of membrane on the shelf today. And he did. He gave me some information. I called the place. They have the membrane. They've got the tape for sticking it to itself. It's a different manufacturer. They're a little farther away, but he doesn't have the tape to stick it to concrete. And so if memory served me, I figured, well, the first place that I talked to, they at least had that part in stock. And so today I could be off and running, and they're on the way, actually. The first place is on the way to the second place. They're closer to me. And I haven't heard from anybody now, and it's getting to be early afternoon, which is rude again, because I've tried carefully to make people aware of the fact that I'm on a timeline and this is a problem for me. So I stopped into the first place, and I said, I'm looking for that. Now I got to go and get the membrane and the tape for that stuff from another place farther away from me. And are we doing like a refund, or are we doing like a major discount on the membrane? And he goes, well, we had the membrane and we had the tape, if you remember. You just wanted the wider tape. And so I realized at that point, yeah, we went around and around and around about all these different things, because they're all sort of proprietary. He carries a different brand, and other brands do have tape that works in both cases, whatever. So I'm trying to get through all these variables on the phone. These aren't simple calls right to start with. And I had to work out how much of a 14-foot wide by 140-foot long roll, would do us, with how much extra versus thicker versus thinner versus different sized rolls. So there's all kinds of stuff we had to wade through to begin with. Are you with me? So come to find out, he's had the membrane, and he's had the tape to stick it to concrete, and he's got the tape to stick it to itself. And so I could take all that with me today while I'm there, and I could get started. And if I wanted the extra wide tape for, sticking to concrete, that's eventually going to come in. And, if I want that too, he can get it to me. And then I say, obviously then I can get the membrane down and get the mesh and the PEX going and leave the edges of it to be taped to concrete for when that tape arrives if I decide I need it. Meanwhile, the seaming tape, I've got it, and I can just keep moving here. All right. And he can do me a discount for the, on the materials to a certain extent for the inconvenience and the runaround to whatever extent that there was one over the tape. So then I'm right there, and it's that much closer to my place, and so I figured, well, fine, I'll accept your reduced prices. And he had been fair about it, and I'd been trying to be fair about it, and overall it had been all right there. Well, we go to load me up with the roll. Now the roll pictured on the box store sites that have websites that have photographs of product, because they're a bit bigger of a business. And I don't know if this business, if I looked, it may have a picture of the product also, but the product photograph makes it look like a 14-foot wide piece of material has been folded at least 3 or 4 times into a roll that's 8, 10, maybe 12 inches diameter and 3 or 4 feet long maximum. But when he pulls out of the warehouse with the forklift, he's got a 7-foot long roll, and it will not go in the work car. So now I'm 45 minutes from home and 30 minutes from the job site, and I could take the stuff and go to the job site and start, racking up billable hours, making good progress, and I cannot get that thing to the job site. So he can drop it off there, and I can take the tapes, which I took, and I can write the rest of today off, or I could go over there and start ripping and tearing on the entryway, which there's part of me that goes, Jazzy, don't go making a bigger mess of the front door situation and then walk away from it for, the better part of a month before you get back, because you'll get into other stuff, and that'll be where it sits as a welcome to the job site every time people come back, because these things have an effect. But I think I should probably go tear that front entryway open. And I don't know that we're going to get right into that. See, this video series, not that this is the least of my worries, right? But I'm not going to cut that into this video if it's about prepping for a concrete pour, right? So I'm going to have to start juggling the different segments that I'm shooting like I did the last couple of weeks, which take a little bit of my bandwidth. Obviously not important whatsoever when compared to the project, so all that stuff comes first. And this is where, I wrote down my contact, I wrote down his number, I wrote down the address and the name of the business, right in my book, right where I know that I've got things coming down the pike and where to call and who to get with about them and stuff. But I did not write down that it was over the double wide tape. And I had waded through so many options that I ended up thinking it was over having the membrane, and I didn't do the thinking on, if I could just get the membrane, I could keep moving until the tape shows up, even if the tape's a week late. And, there's things in there too, like I've taken so much time and information out of the first contractor who got back to me about pouring the floor, including this information about how to go farther away to get some of the stuff that I thought that I wanted, which was good info, that I really feel like I ought to give him the project. And I can't be waiting any longer to get other numbers from other places, because that's sort of a factor of it. It sounded like a really good price. I like to have my bearings on the days, that are in question, as closest to when we're trying to do something as possible with the actual players, when they're really close to their actual schedule, to get the best possible idea of cost. And so it feels like waiting to the last minute, but I really wanted to talk to a couple places, get my bearings. Maybe I very likely don't go with the cheapest outfit, because there's a lot of real cheap concrete, and we've already been bitten a little bit on this project, not being careful enough with our concrete contractors' work. So that's a component. But as of right now, I got to go to something unrelated on the site now to get a few billable hours, which is still good for everybody involved. But that stuff's going to show up tomorrow morning, and then we can get that membrane laid out and we can pick up the next video in the series. And this stuff here will, that I'm about to do will have to come after that. I just want to get that floor in, because then I can get the stairs built inside up to the interior, and it's people can do a loop, and we can get the furnace moved in, and we can lay out the old ductwork and start talking about where we might like to place that, and we can frame up the exterior wall, and that can carry the electrical and the plumbing, and there's so much stuff that can go on in the basement, and now it can't until we get that floor, because we got to have everything cleared out of the way and be ready for it. So this is a major sticking point, and you want to be ready in every way, is all the more I can tell you. And I knew all that going into it, and it's going to be by the skin of my teeth that I keep us on schedule and manage to make a reasonable paycheck during the busy time of year. See, because for me, it doesn't just get moved later into the year or into next. It just kind of goes away, the fact that we had available billable time that wasn't billed to anybody, and I have to watch out for that. But overall, everybody's been good. It was a young, probably inexperienced person that didn't realize not pulling that order on a Friday, whatever occurred there in the warehouse. They're a big business, I don't know. It happened out of state, whatever. So this isn't really about that. It's about these things happen and you got to stay on your toes. All right, we're looking real good down here. Ed was able to get the last few little areas going right down the wall here and fitting around that, yada yada. And I think, yeah, there's room here, and probably for the best to swing wide, maybe on the outside with a PEX route, as shown in my drawing. I don't think that'll hurt anything. I think that's probably the best idea there. We got a couple kind of, piles of mostly foam dust and leaves that have blown in, and we want to be careful. The leaves are coming in now, and between that and the water that might pockmark the surface if it should rain within the first, basically on the day that we pour, I may want to cover those. There's also chunkage like that I just found kicking around in here, and that's where you want that heavy membrane if you're walking around on it later and you step on something like that backed up by the foam, and you slice a hole in a 6 mil kind of plastic barrier or something off the shelf. So that's one of the reasons. One little hole probably won't make a huge difference, but it could make more of a significant difference than you realize, since time's never on your side. Through a little hole, the right moisture circumstance could always contribute sort of a moist spot in the concrete, even if it's just 6 inches in diameter all the way up to a couple feet or whatever other weird, stupid scenario. And then you've got a place where the flooring that you chose is weird or doesn't stick or whatever, or where the paint that you use doesn't stick, or just any stupid oversight like that. You want to avoid it. We did pretty well here. We have, a couple little areas like that are, looks like about beyond 1/2 inch to 3/4 of an inch deflection between two similar areas. Also places where there's two immediate hard references, like the footer on both sides of a corner. I can feel there's a little bit of it. Yeah, he wants to crack open a little bit here, but and the alcove's a little bit like that, but it wasn't worth bringing in a little bit more stone. The concrete will sit it down like that, and that's the end of it. It doesn't take a lot of cycles. So, doing it a little, far more often, there might be a little bit of time we could have spent kind of taking that out of it, but I'm fairly content with this. So if you're watching and you're all the time prepping for pads, I don't think it's that big of an issue. Insulated pads, I mean. So we've got these sheets that should do the garage. If there's 6 sheets there, you can see what 6 sheets looks like here-ish, which would be about what we need. A little bit of leftover there, which I'm not upset about, which we may be able to fill in a couple small areas, even if they're ripped up little slices. They have straight up waste, which I guess you could consider these semicircles. They have one straight side and a couple things here. That's about what we had left over. And then this one half sheet that I mismeasured when I laid out that arc and was wildly off. And I could have cut the rest of what I needed. It could have been an ugly looking thing over here, but I have my pride. At the end of the day, I wanted it to fit like I knew what I was doing, because I do. So we'll use the majority of that sheet somewhere else as well. And we'll work so that if we can save if we can leave one sheet, probably not 2, but if we could leave one sheet worth the surface area, let's make it a full uncut, you know what I'm saying,
factory-sized sheet, and that's good for a lot of different projects, or it could be resold. This particular manufacturer won't take it back for a refund, but no big deal in the scheme of things. There are some places where I might like to put it. You never know, because we're going to be shy when we go up with the styrofoam. I guess it won't make any sense to put something solid behind on that gap between the face of the concrete and the face of the plate. It does grow in some places to be pretty significant, like here, right in there. But anyway, we'll use, regular foam on that. So probably won't end up, unless maybe it'll make sense to put in the rim joist in at least this area here, and then put our bats in to just help that little area, that little space stay and maintain its temperature a little bit better. You never really know what you might need it for on the actual project. So without blathering on and on, this is the state of things here. I'm going to vacuum this stuff up, put the garage by the road. When I have a hand, we'll move these full sheets out. And then I think we're on the hook for concrete by the end of next week. So tomorrow's moisture barrier in here, and then mesh on top by the end of Friday, no problem. And then as far as deciding on the PEX, whether or not and getting that rolled out. Meanwhile, I got to frame this wall in here with the plate that hovers to consolidate all the ends of the PEX. I don't know where the plan puts my planned route out through the wall. If it's close enough or right in this space, then we'll go through there. However, I've also got to sit one block in mortar here and over there on the other, to hold back the garage floor pour. And the remainder of the moisture barrier I want to probably use on the floor up there just as a best practice, since it belongs to these customers, and there probably ought to be enough to do that. And so that begs the question, should we put this on the wall up there? Because of course, see the difference up there is, we're not framing a wall along the inside face. The wall is framed thinner than that and over on the outside outboard of the footprint of the building. So you would always have the exposed 2 inches of styrofoam, of XPS foam, extruded, and that isn't really something that you want to deal with. But then again, if we're putting a heat circuit in that floor, we kind of want to thermally isolate it a little bit from the wall. So we'll likely at least put expansion joint in to work in the way that it does to start with, but also as a bit of a thermal isolation from the outside wall. Usually the garage people, you would normally and that's why it's its own circuit for a variety of reasons, but you would use a thermostat to control just that circuit as a zone, and maybe you'd set it to 40 or 45 degrees. So with a good insulation value in the wall and a little bit of thermal isolation in the floor edges and fully insulated below, and someday either at least put, and that's something he could use his full sheet for, you could line your garage door that he has, which is hard to see, but it's hollow back. See that cavity? You can put 2-inch foam pieces in that and make a poor man's insulated garage door. And at the end of the day, you can keep your paint and your stains and your fuels and your small engines and stuff that people normally keep in the garage. And it can be it's climate controlled at that point. And you don't run into nearly all the problems that you have in the garage that he had before, which was what do you call it? Condensation building up on his tools and equipment that were out there and causing their tool steel surfaces and things to rust, and making it so that you can't have a little workshop out there for a variety of reasons. Even if you could stand going out when it's chilly and it was all laid out and you could do what you needed to do and come back, the health and well-being of your tools and equipment, and the idea that you might leave something out there that can't freeze, we're just getting away from all of that. And I know it feels like too much of a creature comfort or a vanity thing up front, but it really won't be anything, especially if we do the PEX in the floor here to get a PEX circuit out there, and then it's just always there. And that's the type of thing where even if you just hook that one up, you could hook that up to a hot water tank, in like an ad hoc sort of way that places outfits out there. I think it's Radiantech on the internet out of Vermont. They like to tell you that you could do your whole house and plan your whole new build's heat and do everything with a hot water tank, which a lot of people really don't like the idea of, but if I know that it'll work to some extent. So it seems to me like the place to start doing something like that is when you're just running one simple circuit in the garage to keep it from actually dipping below freezing, and that'll be something that's available to them kind of right away if they should want to do that. The problem with the hot water tank is that it is just water, and so if you're not on top of it in every way, if it's not on and we get a freeze, then you've got to worry about it, something breaking because of that. If you want to circulate glycol, and that's something, so the water is good in this floor because it should never freeze here far below the freezing level. And with windows, that like the worst case scenario is people leave windows and doors open or leave the furnace off over a winter or over a period of freezing days for some extenuating circumstances, and the cold air can become freezing cold in the basement, and then it can drill into the floor, which is adjacent to the airspace here, and then that water can freeze, and then you can have a problem there, which is why we want to worry about furnaces being left off in finished construction in general. But because that pad is very close to the outside and is just a garage, there are some reasons why you would run glycol in that, just as, or like any kind of antifreeze or whatever, because then you don't have to worry about that being left off. There's never anything you have to think about with that. But obviously then that's not a hot water tank anymore. It's a closed system with glycol in it circulating. So this is all on my mind because some of those choices disappear for the sake of one small thing that you didn't do at an earlier stage, and now that precludes you ever having those options in the future. So we want them in play at these stages right now. I got the inspector coming to see that the foam's in before we cover it with moisture barrier, and he can't see that. I got the moisture barrier showing up tomorrow morning. I probably already cut in the rant on the phone in the car that I did over that whole debacle, and so there's a couple hours left in the day. And this beauty of this project is if it's not in the tree shade, it's just in the shade of the house itself. This location is a really nice little work job site. I don't have to stand in the beating hot sun to work. So I'll go out on the front entryway and pull as much of that out as I can after I get these garbages to the street. We're still dealing with this pilaster. Let me know if you guys are big fans of this series and you want something to remember it by. Just if you pay shipping, I'll send you one of those for free. So if you want a little keepsake there for your garden or hold your back door open in the summertime and you want me to, I'll sign it. So just you cover shipping. All right, back to work. All right, we got our roll in. It came in that gray sort of heavy plastic, almost like 6 mil, like a contractor bag wrapped on the outside. Then you get down to business here, and this is really getting to be a seriously thick membrane. I don't know what I was expecting. It's actually physically less thick than I'm looking at it and I can see that it's what we need, but I expected in my head for it to look thicker, but it's actually in the feeling of it. It's almost like a sheet of tag board would be if you were to, a poster board, like if you were to cut about that size off from it, it would have that kind of like body, I guess. It's in the body of the material that you notice how heavy it is more so than the edge of it. So that's not anything that you even care about. We're going to get it rolled out in here. I had it in my head that we could do the full length with the 14 feet without any perforations, but I guess I just forgot about that post, which I'm torn on that post. I know the engineering shows that it needs to be there, but I've had it out of there on several occasions and had nothing in there, and there was like no visible deflection or anything. As significant as it is, it's probably far over. It's perfectly necessary, but the visual, you could probably stand a 1-inch tube in underneath. You know what I'm saying? And it would do the same, take the edge off of that span to the same extent. But of course, we just use an average post designed for this purpose that's ready to have top like that welded onto it. And since needing one so thin is very rare, that's not what's commonly available. So anyway, you end up with a big post that you don't think about being necessary, but it certainly is, and it certainly is there. And it's going to mean that we're going to do our first, rather than cutting right at any perforation like we did in these full sheets of foam all the way across, and then having that little orifice or whatever, the opening that's necessary. We're not going to cut all the way across the sheeting or the barrier, because we can flip the one piece of it up. Obviously it's more flexible than the foam is, just in case you're wondering what the deal is with that. And obviously the fewer cuts in it the better, and we've got the special tapes that will break out after that, but we got to get this thing covered up first, and we want to be up on the wall to a certain extent. And then it becomes a question of these inside corners, how to make sure that we have the ability to fully cover and overlap in these inside corners. and we want to leave that shelf that we created for, you know, to screed to it. And so we've got some compound or some complex fitment things that we have to make sure that we can do here. It's going to take some thinking. Yeah, some real head scratchers, because as soon as you cut it, you're going to want to tape it. And if we do too much cutting and taping, it's going to look wildly unprofessional. So try to keep that to a minimum. Okay, well, we've just been very super extra careful that we've got what we want to come tightly up, over, and then back up the wall. all the way around here, and we actually ended up throwing the mesh on, as you can see, because it's holding us far more tightly down and smoothly, and making it more difficult for bubbles and stuff to pop up and out. And you know, if you're working in one area, then that type of thing can translate down and screw you up somewhere else. So then you go fix that and you come back to where you were before, and that's been all messed up. So we're trying not to chase our tail with that. And so we've got it squared out in the room. We were careful about our measurements. You really can't, unless you have a big place to roll it out on a clean surface and translate a measurement from inside to it and cut it and then bring it in and lay it down, all without bringing a bunch of dirt in. Well, then you can do that if you're working on this nice big green lawn outside or something like that. But in our case, I didn't want to drag all this dirt and stuff in, so we went in with the clean roll, and rolled it on the cleanish floor, and then got our measurement. But we can't pull it out that long easily to cut it, so you see us monkey with that situation where we're rolling some of it up and putting a mark on it that we know of, and then measuring from that now that it's flat and whatever. So now we're going to use a couple of levels to push it into those two inside corners and get this leading edge taped, and then come back to here and go down the wall with the tape, and same to there, and then make sure we squeegee it out and go down this wall and go down that end. And at that point, we can get onto this other part of the room and get that far, probably on the other side. And then wherever that leaves our overlapping seam in the middle, we can come down that with the red tape. But for now, we got the mesh in here, like I said, just holding this down. We're gonna end up taking those ends off and a bunch of other stuff, but that's all. It looks like we're further ahead than we really are, but we're that much further ahead when we get to that point, though, too. So I think this is probably the best case scenario for us. If you have more people, then you can get this done probably easier. So let's get this edge taped up, see how that, what is it called? Crete claw. This is yellow guard, and the red tape is their seaming tape. And then the Crete claw is from somebody else. Crete claw. See how that works. All right, we're looking pretty good here. The mesh has been a really good idea. It is, something you want to keep from trying to kick into your toes, especially if you're working without your shoes on like Ed was, in an effort to keep things clean. But I tried just to minimize the trips in and out. And in the end, I can leaf blow. Probably at the end of this day, I'll leaf blow from one end to the other into a corner, and then maybe try to vacuum that out. But at this point, I've got the corners we did, and it's some sort of version of this, which I don't know if this was me or Ed, but a cut that isn't the best example, I guess, but maybe that isn't mine. More like this over here. I'll turn the radio down. Take her easy there. So the one side, straight cut up, that's the one we ended up taping to the edge. And on the other side, I kind of have to, dial it, and it essentially overlaps, but we'll make our piece there, and we'll use the red tape to go from itself to itself, and then the top edge we'll get with the Crete claw. And this is going to be the tricky alcove up front, and these areas on the, where we have a bump out like that, I chose to just come by, and we'll have to add an entire piece of sheeting to there. Got some other business here. Behind these pipes, I'd like to feel that I've sealed all around the pipe, so I almost want to get it to a point where I can Crete claw tape right through. That's good because there's a gap behind them both. Crete claw right through from one side to the other back there, and then try to use the red to go to the pipe. And it's not like there's a ton of pressure with the Radon, but the more of a complete membrane that we can create, the more perfect a barrier, then the far lower chance of it permeating through to the basement. And so the easier thing to do is to go path of least resistance down that site. Foundation drain all the way around and go into the crock. And the crock, if the lid has a gasket on it, which it does, and it's piped over and outside to kick the water out, well, then you can also use a large diameter off the top to nothing. In the tank, there's a sump pump within the tank that pumps the water in the crock. But if you just go from the lid with a large diameter, and normally people go out through the rim joist to a little fan unit that's like kind of white and supposed to like blend in and sealed for exterior, and the fan unit is just all the time drawing negative pressure on the sump crock and that foundation drain. So the easier thing to do for the Radon is for it to just fly away and not come into your house, because I think it's the second leading cause of lung cancer after cigarette smoke, if I remember correctly. So now I guess we'll just rock these tunes the last hour of the day and do as many of these corners up as we can. And we're also going to probably go around with the red tape at the bottom of all those pillars and anywhere else that we think it's necessary. Oh, the pleating, where this had a hard fold to create a roll, it might have dragged or something on the ground, and there's a couple areas where this is going on, which I'll put a square of red tape over it. It seemed to be right because the crease is at the end of the roll, and on the outside corner of the roll, as you drag it along or anything else like that, if it gets a little bit of an abrasion, then 2 or 3 places at about the same interval will have a hole in them, and you want to watch out for that. So anyway, back to work. There you have it. That's our moisture barrier, 15 mil. That's 15 thousandths of an inch thick. 0.015. And the seaming tape in red. In some cases in areas where we didn't have enough yellow material due to the way that flat surfaces fit three-dimensional shapes, we had to build it up with the red tape itself, which is good, and the way that it's done there. You may think that cutting a yellow piece to be added makes a lot of sense, but really it would make sense at a certain scale. After a certain point, well then yeah, we'll make a piece. You know, for example, we didn't fill the alcove with red tape. We made a few pieces of yellow to do the edges. But in most of these corners, it didn't make sense to try and cut little playing card sized or, you know, notebook paper sized pieces of plastic to try and tape their edges all the way down. I use the tape to my advantage in a lot of cases because it's sticky and it will stick to the concrete to a certain extent, but also to the pink foam. And so then I could force, if I'm extending the yellow plastic into the red tape and the tape can stick down to the pink foam, well then I can pull the plastic down and form more of the three-dimensional complicated bends that are happening, where the yellow stuff really doesn't want to bend and crease unless you do a hard crease, and I was, you know, not trying to do that in here. There you go. So then our concrete tape goes to the wall. We have a bit of a discrepancy here because in the length that we rolled out, we measured the room and added 18 inches on the first course to here. And then on the second piece that we measured, we added 20 inches because Ed wanted to be even, have more room for error. But what you end up with is a cascading downhill tape line because of the difference in the algorithm that you use. So I just suggest you use, once you decide on an algorithm that you've tested enough to know that it'll be successful, just stick to the rules of it. You know, it's not going to make a huge difference in terms of functionality, although sometimes these things could make a difference in terms of functionality. We're nearer to forever commitments under concrete over on this side. Over here, the concrete commitments, we have several more inches of material left to do as we may do with it, and then in a lot of cases that is important to have. I didn't want to go way up the wall, you know, unnecessarily high, but, you know, I suppose I could have done so if I felt like it. If I want to add a strip, if we get down to the end of this yellow material in the garage and we could make a 2-foot strip and go all the way around and add it to this, even after the floor is poured, we could pull the Crete Claw tape off and we could use the yellow tape to stick that 2 feet onto the edges of this and go even further up the wall. If we felt that it would be necessary. We're going to get rain hopefully between now and making that decision. So this area that the water used to get to the bottom of the waterproof outside and migrate along the top of the footer and come in on the top of the footer on the inside and then fall off into the stone and into the foundation drain here. Well, that we said we're going to improve with addressing the downspout in the gutter in the future, but that will be a good test here as to whether or not we even see a little bit of moisture, you know, being soaked into the concrete before being carried away. And if that's the case, then we know that we probably want to go a bit higher with this barrier, because that's a what do you want to call that? I know it seems like the best thing to do would be to go right up the inside wall completely, and you might be able to make that argument. Therefore, you've got a complete waterproof surface inside that sheds water inside and out all to the sump crock and goes out. But I'm not prepared to make that decision right now. I don't want to get carried away, but this is the barrier. So we're talking barriers, right? We're talking plastic sheet. I have seen a dozen times now where a thinner sheet, we would have punched a hole through it or scratched a hole through it, or it would have torn, or would have been some other kind of bastard to deal with. So was it worth the special heavy stuff? Absolutely, absolutely, absolutely. And you're going to go get this tape to stick to any kind of self-lubricating plastic sheet. You know, from the same place where, you know, immediately next to the tape is the barrier. So if you're going to go get special tape to tape together your thin, shitty plastic barrier, you really are working uphill and shooting yourself in the foot, not to just get the regular barrier. And as soon as you roll it out in here and pop it and punch a bunch of holes in it, you'll be kicking yourself. Next, we're going to zip tie these wire mesh grids so that they're aligned, and things like this aren't going to be happening. We'll have those stacked on top of one another completely. We want to make sure that our last full course next to the wall is not even a foot is too much. So less than a foot from there to the inside corner, so that we know we can get the last little. I want to make sure that the grid that we make in here out of this mesh will go from edge to edge and carry the design for the PEX layout that I made. I know that the grid's origin point is right in this intersection in this post center line, so that one line of the grid's going to go from center line to center line on these two posts, and the one line of grid is going to go right down the center line directly underneath the center of this main beam, which will mean I think I did end up routing a PEX line on it, so we'll have to just like migrate around the post and jump back onto it in a couple of spots. No big deal. I've already submitted that PEX kind of map or layout designed for a blessing. So apparently locally I can get a 1,000-foot long roll of 1/2-inch PEX specifically designed for radiant floor heat, which should mean it's an oxygen barrier type A. I was very careful to check that it is in fact type A, but for $275 locally is unbelievable. Everywhere else it's at least $600 and some dollars. And one of the places I talked to, it was closer to $1,000 for a roll of that. And it isn't just something that's on the shelf in the box store. And we're going to go with PEX A, and we'll get into why and all of that when we get into it. But I think we're pretty much done with this insulation and moisture barrier series. It's the end of my week, and the easiest thing for me is to organize it by the work week. So picking up next week, we'll get the wire mesh turned into a perfect grid. We'll get our PEX purchased and laid out based on our map, hopefully. And we're going to get the garage cleared out and get foam down in there and barrier down on that, and then the PEX routed on top of that after the mesh up on there. So yeah, we don't need to see the garage happening to cap this video off. I probably will just skip coverage on that, and then you'll just see it show up. I'm just trying to make my life turning these into videos a little bit easier, guys. I know they're super boring and I go on and on about shit you don't care about, and then my time lapse doesn't have any music. You'll notice if you go back into my catalog, this is the first series that has any time-lapse footage at all. Baby steps, okay? Baby steps. I got the tripod mini on the site now, and it can stay here. I still don't have a tripod that's a regular size that I can commit to leaving on my job site, which is annoying. And so again, baby steps. But maybe someday we'll cut some music over those time-lapse segments. But I appreciate everybody watching, and it's designed, the series is supposed to be so like it would be all the information that I wish I had when I started to do this, even though I had the hubris to think that I could take care of it, and I'm pretty pleased with myself, if I do say so myself. So far we haven't had very many problems, but if somebody was as wily as I am and was trying to do this for themselves, this should be a resource for kind of everything you need to know if you've got an average North American construction style residence that, you know, you've decided you're going to put a new basement underneath. And if you're going to run your own project, or if you're growing your contracting business, this is what you've got to know as far as I can tell, okay? And if you're down with it, then you're down with it. And if not, you can keep on scrolling. All right, everybody. That's the end of this work here, I think. And next week, we'll lay out the PEX. Thanks for watching. We'll see you. Here's my issue with thinking I could have put that roll in my car. You type Yellow Guard into Google, and I had tabs on tabs on tabs open, and I was going all around trying to find, you know, the place where I was going to get it. We did a lot better than this on the cost of it, but I guess that, yeah, that's not the roll that I ended up with. So there's one side view, but they give you all these ultra foreshortened, like stock photo, you know, from the manufacturer, depending on where it's listed. This is at Home Depot. But it's so foreshortened, you end up thinking like along the lines of this here, you end up thinking like it'll be 4, maybe 5 feet long, and then I ended up going all the way out to get it and not being able to put it in the car. So be aware of that.